Okay, this is test number 5 extra practice problems. So I'm doing all these problems here. Please pay attention. It's non-calculator active, so we are not using any calculator. The question number 1 said, let f be a function with a second derivative given by f double prime equal x square parentheses x minus 3 parentheses close parentheses x minus 6 as parentheses close. What are the x coordinates of the points of inflection of the graph of f? Point of inflection deals with double prime, we know that. So this is already double prime, so I'm going to make the double prime equal 0. So if I make this equal 0, I'm going to make each piece equal 0. X square equals 0, that one. X minus 3 equals 0. And then I'm going to make x minus 6 equals 0. So this is going to give me my sign chart. I'm going to make a sign chart to see, point of inflection. I'm 50% sure it's this, but when I make a sign chart and see where concavity changes, then it will be 100%. So I got 0 right there. This is going to give me x equals 3, so that's positive 3. This is going to give me x equals 6. This is going to give me a positive 6. So I have 0, 3, 6, my point of inflections right now. So pick something here. I'm going to pick f double prime negative 1. When I plug in negative 1, I am getting positive. Plug in negative 1 here. Negative 1, that's positive. Negative 1 means negative, negative, negative times negative is positive. So it gave me positive. This one, f double prime 1, I plug in. If I plug in 1 here, it's going to also give me positive. When I plug in f double prime 4, so when I plug in this, it's going to give me negative. If I plug in something here, f double prime 7, and it's going to give me positive. You guys can go back and plug in negative 1 here, which was positive. Plug in 1 here, it's going to give me positive. I can change that signs, like this is positive, positive, this is positive, that's all negatives, and this is positive. So plug in 4 here, it's going to give me negative. Plug in 7, it's going to give me positive. I'm plugging in double prime, which is right here. So I can clearly see which one is my point of inflection. 0 is not my point of inflection because the concavity is not changing. This is concave up. This is also concave up. So 3 is my this is concave down and this is concave up. So 3 and 6 are my point of inflections, because there where 3 at 3 my concavity changes from concave up to concave down. 6 is changing concave down to concave up. So 3 and 6 are my point of inflection. So the answer is okay. Question number 2, the graph of f prime, the derivative of the function f is shown to the right. Which of the following statements is true about the f? So we already know if this is f prime, then it means we are talking about increase and decrease. That's what f prime is going to do. F prime is always increase or decrease, and every y value is a slope. And also relative maximum and relative minimum also deal with f prime, like a first derivative. So in this case, if every y is a slope, it means when f prime x is greater than 0, then we say f of x is increasing. If we say f prime x is less than 0, then we're going to say f of x is decreasing. So this is how the f prime and f of x are related. That's how it goes. So since this is f prime and greater than 0 means every y value is a slope. So from here to here, these are all y values, all the y slopes are positives. It means from negative 2 to 0, it's all increasing. So I can say f is increasing from negative 2 to 0. That's true. That makes sense. F is decreasing for negative 1 to 1. I don't know that. F is decreasing from negative 1 to 1. From 0 to 1, it's decreasing right here because all the y values are negative. But negative 1 is increasing. So this one is wrong because negative 1 and 1 is not decreasing. Half of it is decreasing, this half, and this half is increasing. F is increasing for 1 and 2. This is 1 and 2. They said f is increasing. How? These all y values, which means all the y's are negatives and they are negative slopes. So no. Like every y value is a slope. So no, it's negative. It's not increasing. That's wrong. F has a local minimum at x equals 0. This is 0 and they said it's minimum. Minimum means negative to positive, the f prime. This is not going negative to positive. It's going from positive to negative. So no, that 0 is not minimum. F is not differentiable at x equal -1 and x equal 1. It is not differentiable at 1 because it's a cusp, that's true. But at -1, it is differentiable. I'm going to make a negative slope right there. So that is wrong. It is differentiable at -1, but it is not differentiable at the cusp, which is 1. So the answer is B in here. Okay, question number 3. The function f has the property that f of x, f prime x, f double prime are negatives for all real values of x. Which of the following could be the graph of f? So they're all asking, function has the property f of x, f prime, and f double prime. F double prime, or it says if f double prime is negative, right? So negative means it's concave down. F prime x is negative, it's going to have a negative tangent slope. F of x, it's going to have a decreasing. So do you see the wording? F original is decreasing, F prime tangent negative slope, like a tangent negative slope. And this one is concave down. So let's see, all these three things supposed to be in one graph. Let's try number 1. Number 1 is concave down. This one applies, but is the tangent lines are negative when I make a tangent lines? If I make tangent lines here, they are all okay. The following, which of the following could be the graph of f? So these are f's. Okay, so they are all in negatives. These are all positives. I mean, these are all negatives. These are all positives. These are positive. These are negative slopes. So now it's not only decreasing or negative slope. They have both. So this one doesn't work. Let's go for the next one. B. It is concave down. And f of x, which means it's decreasing, and f prime, all the tangent slopes that you make up here is supposed to be negatives. They are all negatives, tangent slopes, and it is decreasing. It's going like down, it's decreasing. So it means this one works. So, but we're going to check all of the other ones. This is also concave down, but the tangent slopes are all positive, so not working. This is concave up, not working. This is concave down and up, both not working. So your answer is B for the question number 3. Question number 4, which of the following statements is true? F of x negative x cubed negative 6x squared minus 9x minus 2. F is increasing. If they talk about increase or decrease, that's the first derivative, f prime x. So we have to look for f prime x, make it equal 0, get the critical points and make a sign chart. Then it will give me increase or decrease. So we have to do all of that. So let's do f prime, take a derivative of this. So f prime x is equal negative 3x squared minus 12x minus 9. You're going to make this equal 0. And since it's a quadratic, we can do the common factor, or we can do the other factors, like the factors when you make 2 of the factors, or a common factor. In this one, common factor is 3. So I'm going to take out the common factor, negative 3. I got x squared plus 4x plus 3. Positive and negative will give me negative. Positive and negative will give me negative. Now, I just wanted to get rid of this coefficient thing. So negative 3 is here. This is a simple quadratic, 3 times 1. So I got x and x. Both of these signs are positive. So one positive, one negative. Now, if they are positive, both positives. So 3 and 1. This will give me the factor for this. And then you're going to make it equal 0. You're going to make everything equal 0. So my sign chart is, I got x plus 1 equals 0, and I got x plus 3 equals 0. So this is going to give me negative 1, and this is going to give me negative 3. So I got negative 1, I got, I got negative 3, and I got negative 1. Now these are my critical points, and let's find out f prime negative 4, and this one is going to be f prime negative 2. This is going to be f prime 0. Okay, let's plug this in. Negative 4, plug in negative 4 here. This is f prime, or you can take this f prime, you can take this f prime, whichever you want. If I pick this, negative 3 plus 1 is going to give me negative 2. Negative 2 times negative 3 is positive 6. And this is 0. So negative 4 is going to give me 0, which I don't know what 0 is what the sign is. So let's try and pick 5 here instead of 4 and see if 4 give me some number. Negative 5 plus 1 is negative 3 times negative 5, negative 4, and negative is going to give me positive, and negative 5 is going to give me negative. So negative times positive is going to be negative. This one, plug in negative 2. That's negative 1. And negative 1 times the negative is positive, and this one is going to give me positive, so it's positive. Next one, plug in 0. If I plug in 0 in 0, it's going to give me negative. So this is all I have. Now I can tell where I'm increasing and where I'm decreasing. They said f is increasing on negative 3 to negative 1. Yes, that's true. Look, it's positive sign, then it's increasing, that's increasing, that's decreasing, and that's decreasing. This is the only one increasing. Then it says f is increasing on this, no. F is increasing on that, no. F is increasing on negative 2 and infinity, no. I think A is the answer for that. Question. Okay, question number 5. They are giving me some tables right there, and this is all the g function, like the originals, and they are continuous on negative 2, 0, all of them, and their g prime negative 1, which is x value negative 1, their slope is negative 2, which means tangent slope supposed to be negative. So tangent slope is negative. Okay, the double prime is greater than 0 means it's concave up. So the easy way to do these questions, these are original functions, and we already know that, and I'm keep repeating this, so please memorize that. F prime x is greater than 0, it means f of x is increasing. F prime x is less than 0, then it means f of x is decreasing. If f double prime x is greater than 0, then it means f of x is concave up. If f double prime x is less than 0, then we're gonna say f of x is concave down. So these are the few things that you guys should memorize it. So now this is g of x function. This means f prime, like tangent slopes are negatives and it's concave up. So we can draw these like it doesn't have to be on scale, but you can quickly draw underneath each one of them. This is 0 and 1, and it goes all the way 5. So 1, 2, 3, 4, 5. And this is negative 0 and 1. So my dot is right here. Then I have negative 1 and 3. This is negative 1 and 1, 2, and 3. And 0, negative 2 and 5. So this is negative 2 and 5. 1, 2, 3, 4, 5. I can try to be very accurate as much as possible. So this one, it said like something like this. Then it said it has to be concave, tangent slopes negative, and it's supposed to be concave up. But if you guys pay attention, it's just a straight line. It's not concave up and down. And I know it's decreasing, like this tangent slope decreasing, but it's not concave up. So this one doesn't work for us. And you can also for the tangent slopes, 3 subtract 5 is going to give me negative 2. 1 subtract 3 is going to give me negative 2. That's why it's a linear graph, because the slopes are all constant. It's decreasing at the constant rate. So this is a straight line. Now let's try that one. We draw this 1, 2, 3, 4, 5. and I have 0 and 1 right there. I have -1 and 4, 1, 2, 3, 4, and I have -2 and 5, which is right there. So this one is gonna go something like this. So it looks like it's concave down up here. So it is concave down and it's not concave up. So even the tangent slopes, if I draw, it's negative, which means this one is okay, but that one is not okay. So this one doesn't work for us either. You have to be accurate, or you can draw these on the graph paper. It will make more sense. So it's all the way to 9. So 1, 2, 3, 4, 5, 6, 7, 8, and that's 9. Then I have 0 and 9, the dot right there. Then I have -1 and 6. So 1, 2, 3, 4, 5, and 6. Then I have -2 and 5. So 1, 2, 3, 4, 5. It goes all the way here. This one looks like concave up. Yes, it's concave up. But am I getting tangent slopes negative? No, the tangent slopes up here looks like positive. If I draw tangent slopes here, like tangent, it's all positive. This one doesn't work either. Now let's go back and draw this one. It's gonna go again 9, 1, 2, 3, 4, 5, 6, 7, 8, and 9. 0 and 9 right there. -1 and 7. So 1, 2, 3, 4, 5, 6, 7. -2 and 5. 1, 2, 3, 4, 5. So this one is going like this. Again, it's not working either, because first of all, it looks linear graph to me. If you're not sure about if it's linear or not, I usually take a slope of that. Like 7 subtract 5 is going to give me 2, and 7, 8, 9, it's 2. So it's linear, like this one. This is a constant rate. That's also constant. That's why it doesn't look like concave up and down. It looks like a straight, not like these ones. So it's a constant rate. That's why this one doesn't work either. Let's try E. E is gonna go 7.5. So 1, 2, 3, 4, 5, 6, 7, 8. I mean, all of them are not. So E is supposed to be the answer, but who knows what if we did all of these something wrong. So let's try this. 1, 2, 3. 0 and 3.5. 0, 1, 2, 3, and 0.5 is gonna go here. -1 and 4. 4 is right there. -2 and 7.5. So 3, 4, 5, 6, 7. 7.5 goes somewhere over here. So it's going to go something like this, and it's concave up, and its tangent slopes are negative. So yeah, this one works. This is concave up. That's true. Then tangent slopes, when I draw tangent lines right there, these are all tangent lines. They are negatives. So that's the answer. Question number 6. In question number 6, picture to the right, pictured. Okay, let's do question number 6. Picture to the right is the graph of f prime, the first derivative of f. If this is f prime, it means every y value is my slope. So I'm going to just write there y value is my slope. Then it says that which of the following values of x does the graph of f have a horizontal tangent? Horizontal tangent means when the f prime axis equals 0. But not a relative maximum or minimum. Positive to negative is maximum, negative to positive is minimum. So we're going to find where the horizontal tangent f prime is 0. Since every y value is this means the slope is 0. So since every y value is my slope, then it means 0 where the y values are 0 for the axis. So -3 has horizontal tangent. -1 has horizontal tangent, and 1 has horizontal tangent, because they all have zeros y values, which means that y value is my slope f prime. But they said find the one with no relative maximum or minimum. Relative maximum or minimum means when this graph is crossing positive to negative, like x-axis from negative to positive, positive to negative. So in here, it's crossing negative to positive on x-axis. So this is technically my minimum. This one going positive to negative, which means that's my maximum. -3, it doesn't cross x-axis at all. So it means this one is not a relative minimum or maximum. So -3 is true. So the answer is only 1. Question number 7. The function f has a derivative given by f prime. What is the x-coordinate of the point of inflection of the graph of f? So point of inflection means a second derivative, and it means wherever the concavity changes. So it means this is f prime. So once I get the graph of this, I'm going to try to find a point where the graph changing tangent slopes. Like we're going to draw the tangent slopes on this graph. So that would be my second derivative. And wherever the slopes changes, that's the concavity. So I'm going to draw this graph on the calculator. I make parentheses and I have a square root of x, close parentheses, and let's go divide parentheses again, 1 plus x to the power 3, and we enter. This is the graph. That's how the graph looks like. So this is my first derivative. Remember that. That's my first derivative. If I want to get the answer for the second derivative, then I have to draw tangent lines over here, small tangent lines. It means something like that. Like for example, that the graph, I'm not on scale, but I'm going to draw. This is not how it looks, but let's try again. It goes like this, something like that. So if the graph look like this, then it means I'm drawing a tangent lines again. So if I draw tangent lines over here, then these are all positive tangent lines. But up here they changed to negative. So it means concave up and concave down. So this is the point where the concavity is changing. So I'm going to go back and check what that point is. This point I'm talking about. So I'm going to go menu and I'm going to go analyze probably, or maybe trace. I'm not doing, you guys pay attention, I'm not doing inflection. The reason I'm not doing inflection because the graph that I have, it's not double prime. That graph is first derivative. So I can do directly that, but I can find, I can do trace and I can do graph trace. So if I move this, I need to get that point right there. This point where the maximum is. So this is the point where the concavity is changing. Like these are all positive slopes, these are all negative slopes. So my answer is 0.473 when you round it up. So 0.473, which is B. And like I said over here, I can make it one more time so you guys can see it clearly. So I drew tangent slopes here. These are all positive. I drew tangent here, that's negative. So positive in negative. So this is where it changes, and that point is 0.473. Because I have to draw tangent slope on the first derivative to get the second. Okay, question number 8. The graph given to the right is the graph of f prime, the first derivative of our differentiable function f. Use the graph to answer the questions. If this is f prime x, then it means every y value is my slope. Okay, remember that. On the interval 0 to 8, are there any values where f of x is not differentiable? Give a reason for your answer. Where this is not differentiable. So I can check everything since we know that every y value is the slope. So I can say the y value here is 1, so the slope is 1, the slope is 4, the slope is 0, the slope is -2, slope is -2, slope is 2. So it's the whole thing is differentiable. It's differentiable. So I'm going to say f of f prime x is defined for all values on 0, 8. closed intervals. F of x is differentiable. For all values on 0, 8. Question number 9. On what interval is f double prime greater than 0 or less than 0? Give a reason for your answer. Double prime means, since this is f prime, how do I get the double prime? I draw tangent lines. Again, like I'm taking a slope of a slope. This is a slope and I'm taking a slope again. So I'm going to draw tangent lines and see where the f prime is greater than 0. So these are my tangent lines. These are all positives. Now these are my negative tangent slopes, all of them. So these are all negatives. Then I have these all positive slopes, so these are all positives. And this one is the slope is -2 and -2, but the second derivative is gonna be slope is equal 0 for that portion because the tangent line is horizontal. Okay, we finished that. Now let's figure it out where the f double prime is 0, greater than 0. So from 0 to 2, it's, let's see, f double prime x greater than 0 on, which one? 0 to 2. And then I have up here, this one side 6 to 8. 6 to 8. These are all because, and we always, after because, whatever the reasoning is, that will be whatever is given. So f prime is given graph, so I'm going to use that. F prime x is increasing. That's it. Now, what do we do? F double prime less than 0? On less than 0, on it's going 2 to 5. Because, and that's the only one, because f of prime x is decreasing. Question number 10. At what values of x does the graph of f have a horizontal tangent? Horizontal tangent means when f prime x is equal 0. So give a reason for your answer. Since this is f prime graph already, so every y value is a slope. So where my slope is 0 for the f prime. So you see this is the x is 0, slope is 1, that slope is 4, slope is 2, slope is -2, and slope is -2. For x equal 4, the slope is 0, the y value is 0. For x equal 7, the y is equal 0. So these are the y values that are zeros. So 4 and 7 are the intervals where the y value is 0 and where the f prime is equal 0. So at x equal 4 and 7, the graph of f have a horizontal tangent. Horizontal tangent because f prime x is equal 0. Question number 11. What is the value of f double prime 4? Explain your reason. Double prime means a second derivative. So what is the second derivative at 4? So this is 4, and second derivative means I have to draw a tangent line on here at x equal 4, which is a negative. But how do I exactly get this answer? Since I don't have any function here, I can use my points, like this is a linear function. You see the tangent and this one is linear. So I can pick 2, 4 and 5, -2 as an order pair, and I can use a secant slope to get the tangent slope. You know, always when we don't have equation, we can't do the derivatives or anything, then we have to draw a secant. We have to find the secant. So f double prime 4 is equal f of b minus f of a. So I'm going to pick these ones, 2, 4 and 5, -2. I can say that's a and b, and this is no, this is f of a, and this is b, and this is f of b. So f of b is -2 minus f of a is 4. B is 5 minus 2, so it's going to give me -6/3, which will make it -2. So my slope is for f double prime 4 is -2. So I'm going to say f double prime 4 is f double prime 4 represents the slope of the tangent line. The slope of the tangent line to the graph of f. To the graph of f prime x at x equal 4. So since this was the first derivative, then I have to draw tangent lines, and a tangent line was exactly parallel to this line, the linear graph that we have. So for 4, I drew a tangent and it was parallel to this one. So I just picked these 2 points because it's going to be exactly the same slope. Question number 12. What is the value of f double prime 8? Explain your reasoning. F double prime 8 means since this is f prime, so double prime means I have to draw tangent line at x equal 8. This is 8, and I drew several tangent lines right there, which means it's undefined. So f double prime 8, I'm going to give them a reasoning. F double prime 8 is undefined. As f prime x is not differentiable. Differentiable at x equal 8. So that's what it is, because we are making several tangent lines. Question number 13, and I can also say that because f prime x has several tangent lines at x equal 8. 13. Question number 13. F prime g of x is e2x fx, and f of 2, this is x, y is -3. What is the equation? Equation means y equal mx minus x1 of the normal line to the graph of g at x equal 8. So we are looking for the equation of normal line to the graph of g at x equal 2. So it means I am looking for this equation y1 mx minus x1, and this is actually would be my answer when I plug in x and x1, y1, and m. So we already know x1 is 2, so I know that y minus y2, y1, and this m, we need to figure it out. How do I get the y for g? Because I have the y for f, but I don't have the y for g. So I'm going to plug in that 2 in the original g function, which is this one, e2 times 2 times f of 2. This is the one I used to get the y value for the x equal 2. So this is going to give me e4. F of 2 is already there, which is -3. I just moved it to the front. So this is my g2. That's my y value. So I'm going to make this positive, and I got 3e to the power 4 equal. Now I'm looking for slope. Slope means I'm taking a derivative. G prime x equal, and that's a product rule, 1f, and this is g. So take the derivative, and this is the formula for the product rule that I write always. F prime is this, so take the derivative of e2x times the derivative of the top, which is 2, keep the g f of x as it is, plus keep the f as it is, times the derivative of g, which is f prime x, because we don't know what f prime is. I'm just gonna do the prime on it. I don't know that function. So now plug in 2 there, because this is what we are looking for, the slope at 2. So this is going to give me 2 to the power 4, and this is going to go f of 2 plus e4 f prime 2. So I already know f of 2 is -3, so I'm going to have 2e to the power 4 -3 plus e to the power 4. What is f prime 2? For the f, they are giving me a graph. I mean, if you guys remember, they said answer the questions below, like this graph I'm going to use for all these questions. So f prime 2, so this is f function, 2 is right there, x value, the slope is 4 for this. So if f prime 2 is equal 4, because we know that every y value is a slope in the f prime graph. So that's x value 2, the slope is 4. So this is what I got over here. Now I have to fix it around, equal negative 6e to the power 4 plus 4e to the power 4. Now e to the power 4, e to the power 4, they are same like terms. So I have to subtract 6 and 4. It's going to give me negative 2e to the power 4. So that's my slope, negative 2e to the power 4. And if you remember, this is my tangent slope because I took a derivative and I plugged in that 2 there. So that's my tangent slope. But the question is asking about normal line equation. So for the tangent slope, that's this. Now, so how the normal line slope is going to go? Reciprocal and opposite. Normal line slope, because we know tangent and normal works together. So my slope is 1 over, it's a reciprocal 2e to the power 4, and instead of negative I have a positive. So that's the slope of the normal line. Now I'm going to make up my equation for which is my answer, plus 3e to the power 4 equal 1 over 2e to the power 4 x minus 2. And that's my final equation. This is my normal line equation. I have to get the tangent slope first, and then I can do the reciprocal and opposite and will give me normal. I just had to change this slope. Question number 14. Question number 14 is talking about, consider the function this, given the table of information below, answer the questions that follows. So I'm going to look at the f prime and f double prime, but you can always make a sign chart if the sign chart make more sense to you guys. I'm going to make a sign chart for f prime of x first. The sign chart, find the critical points. So which ones are the critical points? Where the slope is 0 or undefined. So negative 1 and 2 are my critical points. Negative 1 and 2 are my critical points. So anything less than negative 1 is going to give me positive. Anything between negative 1 and 2 are all negative. Up over here I have all positive. F double prime, how do I do F double prime? Again, make a sign chart of F double prime. You know F prime deals with increase, decrease, and relative extrema. Like relative max and min. But this one, double prime, works with concavity and point of inflection. So let's try this. 0 is the only one here, half, so that's my only point of inflection here. The left side of 0 is all negatives. The right side of 0 are all positive. So yes, this is my point of inflection. This is concave down and that's concave up. Okay, let's now try. I mean, I did just use the table to get that sign chart. Determine interval of increasing, decreasing. Increase, decrease works with first derivative. So this is my first derivative. Where I'm increasing or decreasing? I'm increasing from, I'm going to say f is increasing on negative infinity to negative 1, negative infinity to negative 1, and 2 to positive infinity, because f prime x is greater than 0. F is decreasing. F is decreasing on, so f is decreasing on negative 1 and 2. Negative 1 and 2. Because f prime x is less than 0. Now, next one. Determine and classify all the values of relative extrema. Relative extrema means relative max and min, which also deals with f prime. I already wrote it down up here. This one. So, relative from positive to negative, like negative 1, this is maximum. From positive to negative, that's relative max. From negative to positive, that's min. So I'm going to say the same thing. F has a relative max at x equal -1 because f prime x changes signs, sign from positive to negative. Done. F has a relative minimum at x equal 2 because f prime x changes sign from negative to positive. Okay, done with that question. Now let's see, determine the interval of concavity of f. Intervals of concavity, like they're talking about concave up and concave down, both. That's what the concavity, like it means both. So from negative infinity to half, it's concave down. So f, since they said f, f is concave up, on half to positive infinity because f double prime x is greater than 0. And I can say f is concave down on negative infinity to half, right there, negative infinity to half, because f double prime x less than 0. Now they said determine the values of a and b in the equation of f, and they say show your work. So my equation that I have is right there, and they said find equation of f, show your work. So how I can, and if you guys remember, I told you guys when any variables are missing, it means you have to make the two equations equal each other. But in this case, I don't have any equation. I have to have a x, I have to have a or b, one of those, or I have to have a f of x, like a y value, and I can make them equal each other. But in, like, if you look at it like this, even if I have a y value, but if I don't have a and b, one of those, I can't figure it out the variable, the next one, because two missing variable means I can't do anything. And right here I'm missing everything. Y value, I'm missing x, I'm missing a, I'm missing b. So how do I do that? I'm gonna take a derivative of that function. If that's the case, then always take a derivative. You can take a first derivative, you can take a second derivative, as long as we get the x or a, one of those variables, so we can get the b, or we can have a x or b and we can get the a. So my f of x function, like original function, I'm going to write it here, 2x cubed plus ax squared plus bx plus 5. Then take a derivative of this, f prime x, it's going to give me 6x squared plus 2ax and plus b. If I take a second derivative of that, then it will go smaller. So 12x plus 2a, and that's it. So it means this is okay. I have a and I have x. Now if I know the x, I can clearly figure it out my a, which is gonna be okay if I have that, because I can make this equal 0, the double prime, and I can get all of this. Now let's go back to the, since double prime always give me inflection. So what is my point of inflection here? Like, what is my x value here? So if I get the double prime and 0 is where my point of inflection is, like 0 is a y value, because the double prime has to equal 0, double prime equals 0, the x value is half. Double prime equals 0, then the x value is half. So I'm gonna plug in that half here for x, plus 2a equals 0. This is simplify 6 plus 2a equals 0, 2a equal -6. You divide 2 both sides, I got a equal -3. So that way I got my -3. And if you guys ask me, okay, how would I know that I have to take a first derivative and second derivative? It's easy, because I have to have x value, I have to have one of the a value or b value, then I can figure it out the other variable. But since I don't have all three, then I had to get the first derivative, then I get the second derivative. I could also get the first derivative and make it equal 0, get the critical points like the x value was -1 and 2. But since double prime is also, because the first derivative, this one, if I make this equal 0, even if I have x, I don't have a and b, and I have to have only one missing variable. So that's why I took the second derivative of it, which makes it a and x. If I have x, I'm good with a. Now I'm going to get a equal -3. To get the b, I can plug it in this a up here in the f prime. I have to figure out the x for f prime, and it will give me the b. So for x prime, where I'm gonna make the f prime x equal 0, which means 6x squared plus 2ax plus b equals 0. So now I need x and a. A is there, but I need an x to get the b. So x, where my first derivative is 0 for the x value at -1. So I'm gonna plug in that -1. 6 -1 squared plus 2 -3 and -1, and then I got plus b equals 0. So is this 6x squared for the f prime? Yes. So I got 6 and plus 6 plus b equals 0. So I got 12 plus b equals 0, which makes it b equal -12. So b is equal -12. So that's my last question for this practice. And please let me know if you have any questions. Thank you.